Hi everyone, welcome back to my channel. In this video, we are going to determine and interpret the acceleration of a particle from a velocity function and a displacement function. So basically, when you are given a velocity function and the question asks you about acceleration, then you have to do differentiation once. So A equals to dv dt. If you are given a displacement function and the question asks you about acceleration, then you have to do differentiation twice. So A is also equals to d2s over dt squared. Instantaneous acceleration. If you have a velocity function graph, then the gradient of tangent of the points on the velocity function graph is the instantaneous acceleration, because when we find gradient of tangent, we will do differentiation. So for velocity function graph, when we do differentiation, we have dv dt, and dv dt is actually a. So that's why gradient of tangent at the velocity function graph is instantaneous acceleration. Let's check two different types of velocity time graph. First of all, let's see the linear velocity time graph. So linear graph, that means we have a straight line graph like this. So for a straight line graph, the gradient at any point on the graph is the same. That means, let's say I have two different points here. If I want to draw tangent line for these 2 points, I will notice that the gradient of both tangent lines are the same. Gradient of tangent means dv dt in this case. So that means dv dt is the same. And dv dt is actually a. So that means acceleration is the same. So we can say that it has a constant acceleration. In other words, you also can say that the particle has uniform acceleration. Next, let's check another type of velocity time graph. Let's say we have a velocity time graph that is in the shape of parabola. Let's analyze one by one. First of all, when t is in between 0 to a, we notice that velocity increases with time. This is velocity. Y coordinate is velocity. And follow the curve here, we notice that y coordinate increases. That means velocity increases with time. Next, if for this part of the curve and you would like to plot a point here, we notice that the tangent line of this point slants to the right. That means dv dt is greater than 0. dv dt is actually a, so which means a is greater than 0. So we can conclude that when you see velocity increases with time, actually acceleration is greater than 0. Next, at point A, we notice that for this graph, maximum velocity occurs when t equals to a. So this is the maximum point. And for this maximum point, if you would like to draw a tangent line, we notice that the tangent line is a horizontal line. That means dv dt will be 0. And dv dt is actually a. That means a is 0. So that means we can conclude that whenever we see velocity is maximum or velocity is minimum, then actually a is 0. Next one, when t is in between a and b, we notice that velocity decreases with time. Okay, y coordinate is velocity in this case, and we notice that velocity decreases with time. And if you want to plot a point here, we notice that the tangent line of the point slants to the left. That means gradient of tangent will be negative. That means dv dt is less than 0. And dv dt is actually a. So a is less than 0 in this case. When a is less than 0 means the particle decelerates. So we can conclude that whenever you see velocity decreases, that means a is less than 0. Let's try a few questions regarding this concept. Example 18. A particle moves along a straight line. Its velocity t seconds after passing through a fixed point O is given by v equals to 8t minus t squared. Find the initial acceleration of the particle. So we are given a velocity function, and the question asks about acceleration. So we have to do differentiation once. So I straight away write from v, change to a. Then right-hand side, I do differentiation, 8 minus 2t. Then we check, they are asking initial acceleration. Initial means t equals to 0. So we substitute t equals to 0 into the acceleration function. Then we have a equals to 8 meters per second squared. Next one, B. Find the acceleration when the particle stops instantaneously for the second time. When the particle stops means v equals to 0. So we have v equals to 8t minus t squared. So we let 8t minus t squared equals to 0. Both terms also consist of t. So I do factorization, take out the t. Then we have 8 minus t inside. So we have two answers for t. But they want the particle stops for the second time. So we ignore t equals to 0. We take the answer t equals to 8. Then we read the question again. They are not asking about time. They ask about acceleration. So that's why when t equals to 8, you have to substitute the value into the acceleration function. So we have answer a equals to negative 8 meters per second squared. Next one, C. Find the time in seconds when the velocity is uniform. When the velocity is uniform means the particle has a constant velocity. That means for every second, the particle also have a speed of, let's say, 2 meters per second. So every second, the velocity is the same. Means it didn't accelerate and didn't decelerate. That means a equals to 0. So when a particle has a uniform velocity, that means a equals to 0. So a is 8 minus 2t. We let it be 0. Then we have answer t equals to 4. Example 19. A particle moves along a straight line so that t seconds after passing through O, its velocity is given by v equals to t squared minus 2t minus 8. Find the time in seconds when the acceleration of the particle is 0. So we are given a velocity function and they mention about acceleration. So we do differentiation to get acceleration function. So a equals to, after we differentiate, we have 2t minus 2. Then let's check the question again. They say when acceleration is 0. So we let a, that means 2t minus 2 equals to 0. Then we have answer t equals to 1. Next one, find the range of values of t in seconds when the particle experiences deceleration. Decelerate means a is less than 0. So we take your acceleration function just now, 2t minus 2 less than 0. We bring over the negative 2 to the other side, become positive 2. And the 2 here bring over to divide. So we have t less than 1. Whenever we have t less than a number, we have to write one more line. Because t cannot take negative value, so the latest range will be t in between 0 and 1. And t can be 0. Example 20. A particle starts from a fixed point O and moves along a straight line. After t seconds, its displacement is given by s equals to t power 3 minus 3t squared minus 4t. Calculate the initial acceleration of the particle. So we are given a displacement function. For part A, they ask about acceleration. So we have to differentiate the displacement function twice. So s equals to t power 3 minus 3t squared minus 4t. When we do differentiation for the first time, we are finding velocity. So v equals to 3t squared minus 6t minus 4. Then we differentiate the velocity function again, we get acceleration. So we have 6t minus 6. Then let's check. They ask about initial acceleration. Initial means t equals to 0. So when t equals to 0, initial acceleration. So we sub into the acceleration function. Okay, then we have answer a equals to negative 6 meters per second squared. Next one, B. Calculate the instantaneous acceleration of the particle at 5 seconds. That means when t equals to 5, what's the answer for acceleration? So when t equals to 5, we substitute 5 into the acceleration function. Then we have answer 24 meter per second squared. C. Calculate the acceleration of the particle when it passes through point O again. So when a particle is at point O, that means S equals to 0. So this is the displacement function. We let it equals to 0. Every term also consists of t, so I factorize out the t. Then we have t squared minus 3t minus 4 in the bracket. And then for this bracket, we do factorization again. Then we have t plus 1, t minus 4. Okay, after that, we have 3 answers for t, first of all. T equals to 0, t equals to -1, and t equals to 4. T cannot be negative, so we ignore t equals to -1. For t equals to 0, it just means that the particle starts at fixed point O. Whereas for question C, they are asking when is it pass through point O again. That means we want the answer of time when the particle pass through point O for the second time. That means we have to take the value t equals to 4. So we ignore t equals to 0. Okay, then let's check. They want us to find acceleration. So we take the value of t equals to 4 and substitute into the acceleration function. Then we have answer a equals to 18 meter per second squared. Okay, next one, D. Calculate the range of values of t in seconds when the acceleration of the particle is positive. So this is a direct question. Acceleration positive, so we just do a greater than 0. So this is the a function, 6t minus 6 greater than 0. -6 bring over become +6. Then we have answer t is greater than 1. Example 21. A particle moves along a straight line so that its displacement from a fixed point O is given by s equals to t power 3 minus 5t squared minus 8t plus 12. Express the velocity function and acceleration function. So we are given a displacement function. We just have to do differentiation once to get velocity function, 3t squared minus 10t minus 8. After that, we differentiate one more time to get acceleration function, 6t minus 10. Next one, B. Determine the instantaneous velocity and instantaneous acceleration of the particle when t equals to 3. That means we just need to substitute the value of t equals to 3 into the velocity function. And we will have v equals to -11. And also, same thing, we just have to substitute t equals to 3 into the acceleration function. Then we have answer a equals to 8. Okay, next one, C. Find the value of t in seconds when the particle is instantaneously at rest. When the particle is at rest, that means v equals to 0. So we found velocity function just now, so we let it be 0. Okay, then this is a quadratic equation, so we do factorization. We have 2 answers for t equals to 4 and t equals to -2/3. T cannot be negative, so we put ignore for this. So this is the answer. D. Find the values of t in seconds when the particle is at O. When the particle is at O, that means s equals to 0. So we have displacement function, t power 3 minus 5t squared minus 8t plus 12 equals to 0. And in SPM syllabus, we haven't learned how to factorize a cubic equation. So you can press calculator and get the answer. So instead of pressing degree 2, you can press degree 3 and fill up the value of A, B, C, D in the calculator. So for the value of A is 1, B is -5, C is -8, D is 12. After that, the calculator will give you 3 answers. T equals to 1, 6, and -2. Then you put back your answer in the bracket. Okay, then time cannot be negative, so we ignore t equals to -2. So the answers are t equals to 1 and t equals to 6. E. Find the total distance traveled by the particle in the first 6 seconds. Whenever we want to find the total distance traveled, we have to identify whether the particle changes direction or not. So when the particle changes direction or when the particle stops, V will be 0. So you can refer your answer from part C. When V equals to 0, T equals to 4. That means this particle changes direction when T equals to 4. So when we want to find total distance traveled, we have to separate it into two different parts. Okay, the first part is the distance traveled by the particle when t equals to 0 until t equals to 4. Another part will be the distance traveled by the particle from t equals to 4 until t equals to 6. So S4 means we just have to sub t equals to 4 into the displacement function. Minus S0, we substitute 0 into the displacement function. Plus, this is plus, S6 minus S4. So we sub 6 here, minus, we sub 4. Okay, it's better to put modulus so that we can make sure that the answer for distance is positive. So after we press calculator, we will get the answer 84 meter. Example 22. The diagram on the right shows a displacement function, velocity function, and an acceleration function for a particle which moves along a straight line and passes through a fixed point O for t in between 0 to 4. Okay, so we have displacement time graph, velocity time graph, and acceleration time graph here. Based on the graph, determine the initial velocity of the particle. So whenever we see the word initial, means t equals to 0. So we check this is the velocity time graph. When t equals to 0 means on the y-axis, v equals to -2. So initial velocity is -2. B, the time in seconds when the particle passes through the fixed point O. Particle pass through fixed point O means S equals to 0. So we check this is the displacement time graph. When S equals to 0 means it's on the x-axis. So on the x-axis, t equals to 3. So the time is t equals to 3. Next one, C. Find the minimum displacement in meter of the particle. Minimum displacement means we have to look at the displacement time graph. The minimum point is -4. So minimum displacement, -4. Next one, D. Find the total distance traveled by the particle in the given time period. So total distance traveled, we have to look at the displacement time graph again. So from -3 to -4, if you put a larger number minus a smaller number, then you don't need to put modulus, also doesn't matter. So -3 minus -4, we have answer 1. So this is from this part to this part before it changes direction. Next, after it changed direction, we have this part. Okay, then the distance will be 5 minus -4. So 5 minus -4, answer 9. So total, we have answer 10 meter. Next one, E. Find the range of time in seconds when a particle moves to the right. When the particle moves to the right means V is greater than 0. So let's check the velocity time graph. This is velocity time graph. That means the y coordinate of the graph is velocity. And we want velocity greater than 0, means y coordinate greater than 0. When y coordinate is greater than 0, means the graph is above x-axis. So means we are choosing this part of the graph. And when we want to read the range of time, it is t greater than 1. So we have answer t is greater than 1. Example 23. The diagram shows a displacement time graph of a particle moving along a straight line for t seconds. The equation of the curve PQ is S equals to ht squared plus k. So let's check where is P and Q. So P is here, Q is here. S equals to ht squared plus k is a quadratic equation. So we see this is a part of parabola. So that means for this equation, it only applies for this part of the graph. Then let's check. The points P, Q, R, and S are given. Then find the values of H and K. So we have S equals to ht squared plus k. And for this part of the graph, there are two different points here. This is 0, 1, and this is 2, 3. So we just have to substitute both points into the equation. At 0, 1, we sub S equals to 1, T equals to 0. Then we have K equals to 1. Okay, then 1, we sub back into the displacement function. And then we substitute 2, 3. S equals to 3, and then T equals to 2. Then we have answer H equals to half. B, find the instantaneous velocity of the particle when T equals to 1, 3, and 5. So this is the displacement time graph. And we just found the value of H and K. So we substitute back into the function. We have S equals to half T squared plus 1. To find velocity, we have to do differentiation. So V equals to T power 1. And then differentiate 1, answer is 0. So V equals to T for this question. Okay, let's check. Find the instantaneous velocity when T equals to 1. So when T equals to 1, we have V equals to 1. When T equals to 3, we have V equals to 3. When T equals to 5, we have V equals to 5. That's it.